Welcome back to the last video of Linux Privilege Escalation room. And I know this has been too much and too long on this room, but I wanted to make sure that you grasp the contents. So that's why I divided the videos per one, two, or three tasks. So basically in this video, we are doing the last two tasks. Task 21 is not required. You can just click on answer and you will just complete it. So basically, we will run NFS and kernel exploits. So upon finishing this room, you will have learned all of the, not all actually, let me say 60 to 70%, this is disappointing, right? 60 to 70% of the Linux privilege escalations techniques. And it's enough that if you have learned all of these techniques and you have grasped on the contents and the foundations, actually you will be able to conduct privilege escalation in any Linux system. So in this video, we're going to go over NFS and kernel exploits. We will do privilege escalation using the NFS and the kernel exploits. So do that. You guessed that right. We will just start the machine. So we start the machine and we log into the machine. So the first thing, we want to find a way, all right, to escalate our privileges on this machine, knowing that the machine has an NFS share. So basically, you landed the first foothold on the machine, okay? And you know beforehand that the machine has NFS file share turned on. So what you want to do, you want to enumerate the configurations of the NFS share. Most NFS shares, the configurations of these shares are located at etc, or you can just display the configuration by typing cat etc/exports. So let's go over the configuration. So we see the share is located at /temp, and these are the configurations. Among the configurations we have read write, and we have no root squash. No root squash is actually it means that if the user is root and the root squash is not enabled, right? In this case, it's not enabled, right? So the user will be set to root. It's the vice versa, or the opposite of if the root squash is disabled. When the root squash is enabled, so if you want to enable the root squash, you're gonna have to remove this one. So once you enable root squash, all right, if the user is root and the root squash is enabled, the ID of the user who will log into the share will be nobody, which is actually it's better to just enable root squash. Leaving root squash disabled is not good, since you will be able to upload files to that share, which is temp, and run these files or binaries as the root user. So if you go to temp, you see we have useless and backup file. If we list the permissions, see here the permissions on the ownership are to root user. That's why if the root squash is enabled, all right, and a user has logged in to the file share, let's simulate this. All right, so split and okay, so here su to root on my machine. Actually, I don't know the root password. I don't think enough. I don't know the root password. So sudo -i. Okay. Right. So let's make a directory now. So see where we are. pwd at the root directory, make directory /temp/nfs. So here I am making a directory. I want to dump all of the files to that directory. So I want to connect to the NFS share and just retrieve all of the files and store them in the NFS directory. So in order to do that, I have to mount the share. So we use mount command -o, define the permissions, read write, defining the version, which is 2, and then I define the IP address of the machine which I'm connecting to, and then define the path to the NFS share. On the left, the path is /temp, so /temp. Okay, and now I define the destination directory to which the contents of the share will be dumped and copied. So /temp NFS. Okay, now given that the no root squash or the root squash is disabled, I will be able now to just dump the files to that directory, and now whatever file I put in the temp NFS share will be synchronized to that NFS share and possibly will be run as root. So create now let's examine the content ls cd to temp ls cd nfs ls. So actually we have just dumped the contents of the NFS share. That's great. Examine the permissions and indeed root user. So basically here what we will do now, we will just generate a payload, put the payload in the mount point, and since the mount point is synced to the share, the payload will appear now at the remote machine. So, and since root squash is disabled, the payload will execute as root, as we will see. So use msf venom, define the platform, Linux architecture, probably it's x86 / and now execute. So I want just to create a payload that executes a command only. So the command, I define the command by defining the cmd parameter equal, of course, bin bash. -p, I want to preserve the permissions. That's why I put -p. Define the extension of the file or the payload, and then I define the destination path /temp /nfs /shell.elf. Okay, so now we created the shell. Let's make sure that it exists, shell.elf. Now, before making any changes to the remote machine, just make sure the shell is executable. So you give it permissions with this chmod command plus xs. So here I give it execute permissions and give it the set suit bit set. Make sure to include both permissions, all right? Else will not work. Temp, define the path to the shell. Okay, easy, right? Okay, now guess what? We're gonna switch now to the remote machine and make sure that actually the shell is there. Ls, yes, it is here. Okay, examine the permissions. Wow, as you can see, the shell now is under the root user. And that's, of course, thanks to the root squash. If root squash was enabled, whatever I upload here will be under the nobody. That's why make sure to enable the root squash. Remove this one if you want to work with NFS share. Okay, what to do next? The last step is to just boom, execute that and get the root user. Shell. Oh, okay. Shell ID, and yep, you are the root user now. Okay, there is one question to answer. It's asking what is the name of the option that disables root squashing. So as we said earlier, remember that the root squash is controlled by this in this line. So basically, in order to enable it, just remove this one. Disable it, put no underscore. Of course, the better option is to enable it. All right, now finished with the NFS method. Now we will jump to kernel exploits. See how we can use kernel exploits to conduct privilege escalation. So normally, kernel exploits. Let's first exit. Let me remove the directory NFS from my machine. Just do a bit of cleaning up. Device or resource busy. Okay, let's exit. All right, now remove. I guess we have to. All right, okay, I'm gonna leave it. I'm not gonna spend time on that. So let's close this one and switch back to my user. So the next step now, we will reconnect to the machine. Okay, and look for a way to just do privilege escalation relying on kernel exploits. I'm going to tell you how we know if there is a kernel exploit on the machine or not. So the first thing to understand before initiating any sort of kernel exploits on the machine is to know that kernel exploits, when executed, will make the machine unstable. So if you are doing that, or if you're doing pen testing for a client, make sure just to put a thin line between CTFs and real pen testing. So in real pen testing, we leave kernel exploits at the very end, all right? Because kernel exploits tend to make the system unstable, and it may interrupt business operations. If the machine that you are doing pen testing on is used for production or is considered as a server. So leave kernel exploits till the end and make sure to consult with your colleagues in the pen testing team or your supervisor before initiating any kernel exploits. All right, so now we are on the machine. So you landed your first foothold on the machine. You want to know now if there is a kernel exploit on the machine or not. So what you're going to do here, we're going to just check out the version, uname-a. So this version of Linux is vulnerable to the dirty cow exploit. How to know that? Or you can also cat proc version. This is another way to find out the version of the operating system. Now, what we can do here, we can just take this one and Google it. AMD, let's AMD 64, that's right. So it's here. So the exploit is dirty cow, and if you do CTF very often, you will know that dirty cow is very famous, and many people just encounter the dirty cow while they do CTFs or even pen testing. Dirty cow is old exploit, and I don't think there is real server or real machine on the internet used for production that is vulnerable to dirty cow. So anyway, just this is the exploit. You go ahead and download it. Now, suppose that you don't want to check out the version, you don't want to do all of that, you just don't want to automate the process. Suppose you have many machines to do pen testing on. So you're not gonna just go ahead and waste your time, check out the version, and then you go to Google, check out the exploit, spend time Googling. No. So what we're gonna do here, you can automate the process by using Linux Privilege Escalation scripts. There are various Linux Privilege Escalation scripts. Among them is linpiece, you know that. And also on this machine, the owner or the creator has uploaded one script for you. So we can go to cd home, user tools, kernel exploits. So here the owner has uploaded you the Linux exploit suggester, which is a popular tool to check for Linux exploits. So we cd to that tool, and we are here. We have the binary. It is written in Perl, so run that using Perl. Let's take a look at the output. So the tool has run and has made a dive on the machine, and it's telling you that you have around here it's the version, and here are the possible exploits. American Sign Language, CAM, PCM, Dirty Cow. Here's our one, Dirty Cow. Of course, you can go ahead and try all of these if you are doing that in a CTF scenario. But if you're doing that again in a real machine, don't go ahead and try all of them. Replicate the VM or replicate the machine to a virtual machine, and then you can do your testing. So, Dirty Cow. Now, we have to download the Dirty Cow now. Luckily for us, the owner has just created the Dirty Cow for us here. So we can just go ahead to Dirty Cow. So we have a C file. Let's examine the file. All right. So Dirty Cow root privilege escalation. Here, the instructions to compile it. And here, you run it with this command. So what it does, backing up user bin password to temp pack. The first thing it does, actually, it just copies the password file or the password. The file contains the all right, this is the binary. All right, so it copies that binary, which is responsible for changing user password to temp back, creating a backup for that. mmap, mdevice, ptrace, user bin password, who am I, root. Okay, so what the exploit does, it is creating its own version of the password tool. The version of the password tool it creates, it just executes or elevates the privilege of the user into root one after taking backup of the tool and storing the backup in temp/back. Let's check it out. Now, let's first compile GCC. Let me copy that. /home/ yeah, I have to get smart and just copy that. Dirty Cow. This is the C file, and now I define the output name. Make it C0W. C0W. Okay. Execute C0W. Okay, I guess it's finished. Now you will be tempted to just type ID. The exploit didn't work. No, we're not finished yet. We're gonna have one step left. You're gonna have to execute this one because the exploit has created one binary. The file has been created by the script, so we just go ahead and execute that. Oh, now we are root user. See, as you can see, we have root ID. All right, you want to get things cleaned up. What you're going to do now, we're going to go to temp. Temp. You see there is back file. What you will do now, you will just type mv temp back to user bin. Here we return the file to its original state. If we execute user bin password now, it will be different. User bin pass. So now, as you can see, the original binary is running. All right, so that, I don't know. I think I'm stuck here. I can't type anything. All right, so fine. Right, so that was about today. One last thing before I go. Here, make sure to check out home user tools, privilege escalation scripts. Let's check out that. Here, the owner has created a directory of the Linux Privilege Escalation scripts that you can use. Linux enum, linpiece, lsc.sh. You can find them on GitHub and download them in order to automate the process. All right, if you have many machines you want to do pen testing for, and just you want put the process into the auto mode, you can just use one of these scripts. So that was for today. Before I go, one thing before I go. So basically, I get asked a lot about the notes I am using. So basically, guys, I've created one brain map for cybersecurity called the cybersecurity manual. So here I put everything, all my notes. Some of the notes I take them from my work, some notes taken from field work, some notes taken from just doing CTF, some notes taken from doing some other challenges. So I make sure all of these notes are written and documented here in case I want to get back and use some of them. So you can get the same notes actually by just subscribing to the channel membership. For Linux Privilege Escalation, I have compiled all of the techniques and the methods to conduct privilege escalation into one root. Oh my god, into one note document. By subscribing, you will get the notes, and of course, I update these notes on a regular basis, so there will be many versions of the notes. Technically, it's infinite, right? So, see you in the next video.